Hey everybody, and welcome to yet again another online math lesson. Just got done entering in some grades for 11.1. Saw that it went a little bit worse than in chapter 9. Keep at it, guys. Keep doing what you need to do. Keep grinding. Go ahead and email me if you have questions, please. I know we're getting into some stuff that maybe is a little bit more difficult. We're going to be talking a lot about fractions. Chapter 11 is all about fractions. It's fractions with exponents, with polynomials. That's what rationals are. So we're going to do a lot of fraction refreshing. Okay. So today, 11.2. Multiplying and dividing rational expressions. Before we get into rationals, which have variables, let's remind ourselves how to multiply fractions. The rules for multiplying fractions are top times top, bottom times bottom. You just multiply the top numbers and you multiply the bottom numbers. So 3 times 7 is 21, 4 times 5 is 20, and you're done. There you go. Over here. Now, this is going to come in later, okay? It says factor and cross reducing. So look here. We have a 12 being divided by a 5. Now this 12 and this 5, they don't reduce. But with the rules of multiplying fractions, they become the same fraction. So it doesn't matter that this 12 is with the 5. The 3 can go into the 12. So this 3 can cross reduce with that 12, making it become a 4. And the 3 becomes a 1. So the 3 divides into the 12, making it a 4. The 5 can divide into the 10, making it a 2. The 5 becomes a 1. And now we use our multiplication of fraction rules. We multiply the top numbers, which are now 4 and 2, and we multiply the bottom numbers, which are 1 and 1. So 4 times 2 is 8, 1 times 1 is 1, 8 over 1 is just 8. Cross reducing fractions. So now let's try that. So the rules for multiplying rational expressions are no different than the rules for multiplying numerical fractions. You still multiply the top numbers and you multiply the bottom numbers. You can cross reduce if you can, but remember, you must always state the restriction. The restriction is what makes the denominator equal 0. So let's look at this first problem here. We have top numbers are 6 getting multiplied by a negative 2. We have an x to the second getting multiplied to an x to the third. A positive times a negative makes this whole fraction negative. 6 times 2 is 12. And remember your exponential rules. 2, the 3, they add to be 5. In order to multiply your bases, you add the exponents. Da-dum-da-dink, you're done. Let's go to the next one. Up, 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 up. I just forgot my what? My restriction. It's very easy to do, but it's very important you don't. What is the only thing that would make this denominator 0? Well, it's in fact 0. So you cannot forget your restriction. Okay, this is just a star, meaning that this is the right answer. That's not the right answer because I forgot to state my restriction. And the only thing that makes these denominators 0 is 0. So x cannot be 0. So let's go to the next one. Again, we're going to multiply top times top, and bottom times bottom. Okay, so to multiply the top numbers, x times x is x squared. X times minus 5 is minus 5x, but we're going to have a minus 7x, which makes a negative 12x. The 7 and the 5 makes negative 12, and positive 35. And then we have the denominator. X times x is x squared, and x times 3 is 3x. Don't forget to state what your x cannot equal. It is always what makes your denominator 0. Always look at it in factored form. What makes this 0? You set both of these equal to 0 separately. So one thing it can't equal is 0. But what makes x plus 3 equal 0? Well, subtract 3, and you get that x cannot equal negative 3. So that would be your entire answer. Go to the next one. Top times top, 5 times 12. Bottom times bottom, 2y times 3y to the third. 5 times 12 is 60. 2 times 3 is 6. Y becomes y to the fourth. You must reduce if you can. 6 divides into 60 10 times. So your answer is 10 divided by y to the fourth. Don't forget to state your restriction. What can our variable, which is now y, not equal? The only thing that would make it 0 is 0. Go to the next. Nothing reduces here. The x's cannot reduce. The x minus 2 cannot reduce with the x plus 2. They must be exactly the same in order to reduce. So nothing reduces. So we just multiply. I'm going to multiply it here. Okay. X times x is x squared. X times 2 is 2x. X times x is x squared. X times negative 7 is negative 7x. Negative 2 times x is negative 2x. And negative 2 times negative 7 is positive 14. Those two things can combine. X squared plus 2x divided by x squared minus 9x plus 14. But what can x not equal? What would make this equal 0? Well, positive 2. What would make this equal 0? Positive 7. So the restrictions on your variable would be 2 and 7. You cannot plug these numbers into the statement. Now we're going to have cross-reducing, and you'll recognize it first says factor. Factoring is extremely important in this chapter. So we're going to factor anything and everything that can factor. The only thing that can factor is this thing down here. So we're going to have x divided by 7 outside of x minus 3. That gets multiplied to 7 divided by x to the third. And here's why this is helpful. This 7 can divide away with that 7. It couldn't divide away with the 7 here. It needs to be multiplied. You can't just take this 7 and that 7 away because that wouldn't do anything with this 21. The 21 must become a 3. So the 7s go away and they become 1s. X times 1 is x. And x minus 3 times x to the third becomes x to the fourth minus 3x. State your restriction. What would make the denominator 0? Well, what makes this denominator 0? 0. And what would make this 0? Positive 3. So your answer is x divided by x to the fourth minus 3x, and x cannot equal 0 and 3. That's not a J, that's a colon. It kind of looks like a J, doesn't it? A lot more factoring going on here. Okay, we have x plus 5, that doesn't factor. However, over here, what multiplies to a negative 20 but adds to a positive 1? Positive 5 and negative 4. That makes a negative 20. It adds to positive 1. Go to this one. What multiplies to a negative 4 but adds to a negative 3? A negative 4 and a positive 1. What's the only thing in common? A 5x can be taken out. What's left behind? X plus 3. So here is our factored form of this original statement. Anything that is opposite of each other, that is exactly the same, that x minus 4 and that x minus 4, they divide away. Does anything else divide away? Well, x plus 5 times x plus 5 doesn't divide away. The x plus 1 doesn't. The 5x times x plus 3 doesn't. So this is where we're left. So let's multiply the top. That is a perfect square. It's going to factor to x squared plus 10x plus 25. I said factor, I should say distributes to x squared plus 10x plus 25. This statement was at one point 5x squared plus 15x. We might as well rewrite it as 5x squared plus 15x. Then you multiply it by x plus 1. So you have x plus 1 being multiplied by 5x squared plus 15x. X times 5x squared is 5x to the third. X times 15x is 15x squared. But you're going to add that with 5x squared, which makes 20x squared. And then 1 times 15x is 15x. That's the denominator. The top is still x squared plus 10x plus 25. But now we must state our restrictions. What can x not equal? It cannot equal any number that makes these denominators equal 0. So look at your factored form. You have x minus 4, you have x plus 1, you have 5x, and you have x plus 3. Let's look at the factored form. Yes, this went away, right? These went away, but they are still inside of the original problem. So therefore, the first thing it can't equal is positive 4. Positive 4 would make this 0. Negative 1 would make that 0. 0 makes this one 0. And negative 3 is our last one. So that one had lots of restrictions. It has 4 values that x cannot equal. Go on to the next page. This side was all about multiplying fractions. So what's the back side all about? Well, the back side is about dividing fractions. And you'll remember I said this symbol is a symbol that you don't use anymore. Okay? This is the way you're going to see it for now on. But these two things are the same thing. It's this fraction being divided by this fraction. So over here, it's this fraction being divided by this fraction. How do you divide fractions? Many of you know it as copy dot flop. Even though I don't totally understand flop. I think it should be copy dot, not flop, but what? I've said this before. Flip. Copy dot flip. So, we're going to copy the first fraction. We're going to change the division into multiplication. And then we're going to flip the second fraction, which then makes that equal 25 over 21. Same thing here. Copy the first fraction. This is your first fraction. You copy it. You put a dot. And then this is the fraction that you flip. It becomes not 15 over 2, but 2 over 15. Now these can cross-reduce. 12 and 15 is divisible by 3. It goes into 12 4 times, and it goes into 15 5 times. Multiply straight across. 4 times 2 is 8. 7 times 5 is 35. Those are your two answers there. So we're going to now take this same idea and we're going to apply it to variables. Dividing doesn't change. You still use copy, dot, flip. In order to do these, especially this first one here, we're going to factor. Let's factor it first, and at the same time, I'm going to flip this fraction. Ding, 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 ding. Difference of squares. X squared minus 25, a difference of squares. So x plus 5 times x minus 5 over, the only thing I can do is take out a 4 outside of x plus 7. Put a dot. I'm going to flip it. So the x minus 5 is on the bottom. And the factored of this is going to go to the top. What multiplies to 14 but adds to 9? 7 and 2. So I have a 7 and I have a 2. Anything that can divide away does divide away. X plus 7, x plus 7. X minus 5, x minus 5. Leaving me in my denominator just a 4. And leaving me in my numerator x plus 5 times x plus 2. X times x is x squared. X times 2 is 2x, but that's going to add with the 5x, which makes 7x. And 5 times 2 is 10. And that's divided by 4. State your restriction. Little bit different here. The only thing that never was in the denominator is this. This is the only thing that was never in the denominator. This is the denominator right now. This is a denominator right now. But also this, when you flip it, becomes a denominator. So you have to look at what makes this thing 0, what makes this thing 0, and also what makes this one 0. So, negative 7. X cannot equal negative 7. X cannot equal negative 7, but we already have it. Negative 2. Positive 5. Those are all your restrictions. All right, go over to this statement. Little bit different as we have two variables in the same equation. This is how it's going to be written from now on. As you can see, the next three problems are all written not using this division symbol. It's using a fraction for the division sign. So this is not going to be the way you see it anymore. It's going to look like these three. And I know these three look a little scarier, but this is the way it's going to be shown to you. So we copy the first fraction. We put a dot. We flip the second fraction, which puts the x plus y on the top and x times y on the bottom. So we have x plus y here. We have x plus y here. Those x plus y's divide away. We have x here and we have x down here, so those x's divide away. These x's divide away, leaving us just a y in the denominator. So we have 1 divided by y. But again, we have to state our restrictions. Now here's what, it's a little tricky on this one. What makes x plus y equal 0? So you'll look, x plus y is in the denominator. The question is, what makes x plus y equal 0? Well, subtract y over. What makes this equal 0? Well, x equaling negative y. So what can x not equal? Well, it can't equal negative y. Now that's a lot of numbers, but it cannot equal negative the same value that is for y. What else can x not equal? Well, this x is in the denominator. X cannot equal 0. So that is not necessarily a value, but it is also a restriction on the variable. X cannot equal negative y, because you take x plus y set equal to 0, and you find that. Go to the next one. So this is a little bit weird, I understand, but this is a fraction. What is this fraction over? 1. So it flips it. At the same time, I'm going to factor it. What factors out? A 3x. What does that 3x leave behind? An x plus 4 divided by a 5x. Multiply it by this fraction flips. And this is why I like to put that 1 down here, because that fraction flipping makes a little bit more sense if you understand that there is actually a 1 in that denominator, because now there is a 1 in the numerator. 1, and let's factor it. What multiplies to 4 but adds to 5? 4 and 1. So x plus 4, x plus 1. X plus 4 divides away with x plus 4. The x down here divides away with that x up there, leaving just 3 times 1 in my top, so 3 in my top, and just leaves a 5 times an x plus 1 in my bottom. So a 5x plus 5 in the denominator. So then, we must state our restrictions. X cannot equal. It cannot equal anything that makes the original denominator 0, which is 5x, which is 0. The only thing that makes that 0 is 0. 1 can never be 0. This 1 is a 1. It's always a 1, so there's nothing that makes 1 0. But what makes this one 0? Negative 4 and negative 1. And there's your answer. One last problem to do. Copy the first one. Put a dot. Flip it. When I flip it, I'm also going to factor it. Ding, 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 ding. Difference of squares. That factors to x plus 2 times x minus 2. Divided by x plus 3. The x minus 2 divides away with the x minus 2. All you're left with is 1 times x plus 2, so it's just x plus 2 in the top. That's a 2. And an x plus 3 in the bottom. What can x not equal? It cannot equal anything that makes this denominator 0. This original thing here, it gets moved to the bottom, and that this is a denominator as well. So it's this one, and this one. It's the only one it's never not is this one. You don't have to worry about this one, but you got to worry about this one, and this numerator, and this denominator. What makes negative 2 0? Positive 2. What makes positive 2 0? Negative 2. What makes 3 0? Negative 3. And there are all your restrictions. X cannot equal 2, -2, or -3. That is how you multiply and divide fractions that have variables in them. But as you saw, it's really not any different than multiplying regular fractions together. Don't got anything else for you this week. Work on the 11.2 multiplying and dividing rational expressions Math Excel assignment. Keep going with everything that you guys are doing. Keep up the good work. And I'll be talking to you again in a week, covering 11.3. Have a great week, you all. Bye-bye.